Today's tutorial is about congruent triangles and other polygons. There are a couple important things to keep in mind when you're dealing with congruent triangles and polygons. In order for them to be congruent, in order for two triangles or polygons to be congruent, their angles and sides must not only correspond to each other, but also be congruent. So let's talk about that a little bit. First, I'm going to bring in two polygons. Here we have two pentagons. From the congruency tick marks I've drawn, you can tell which sides are congruent. For example, let's call this top pentagon, I'm going to mark it in blue. This will be pentagon number 1, and the other pentagon will be pentagon number 2. In pentagon number 1, you can tell that side AB corresponds to side PQ in pentagon number 2. So I'm going to write that over here. Side AB of pentagon 1 corresponds, it's congruent to side PQ of pentagon 2. Let's take a look at maybe side DE on pentagon 1. You can tell that with side DE, it's congruent to side ST on pentagon 2. You can tell that it's congruent because it's got those red congruency tick marks. Side ED is denoted by the Roman numeral 4 there, and side TS or ST is also denoted by the Roman numeral 10. So you can tell that on any two pentagons or any two polygons, you can find out which sides are congruent and which sides correspond to each other by checking the congruency tick marks, or by just checking to see if they had actual side length input. For example, what if side AB didn't have a congruency tick mark, but you knew that it was 6 centimeters long? And what if pentagon 2 side PQ didn't have a tick mark of congruency, but it was also 6 centimeters? Then you yourself could put in those red congruency tick marks to remind yourself that these two pentagons have these corresponding congruent sides, AB and PQ. So, another important thing about congruent polygons is that they have corresponding congruent angles. So let's draw these guys in. You'll notice that the angles in polygon 1 correspond to the angles in polygon 2. For example, let's take a look at angle measure B. B has this nice simple blue line here denoting that it is congruent to angle Q on polygon 2. So if you wanted to take some notes on those on the side, you would say that angle B of polygon 1 is congruent to angle Q of polygon 2. Now take a moment for me to look at the angles of these polygons and take a guess from me as to which would be congruent. Alright, a good idea would be to pause the video there if you'd like some more time. I'm going to give all the congruent angles to you, and you can check and see if that works with your answer. Angle C on polygon 1 is congruent to angle R. Angle D is congruent to angle S. Angle E is congruent to angle T. And angle A of polygon 1 is congruent to angle P of polygon 2. Now that we know that they all have congruent and corresponding angles, we can name them. In order to name the polygons, we need to name them in order of their corresponding and congruent parts. So what we're going to do is I'm going to write polygon 1 in blue, and I'm going to say that polygon A, B, C, D, E is congruent to what polygon and polygon 2? You have to name them so that the side lengths of the angle measures also match up to polygon 1. So in order for it to go in the same direction, A, B, C, D, E, what I'll look at is that A to B in this first part right here, A to B contains this red single congruent tick mark. That same red congruent tick mark is contained inside PQ on polygon 2. So AB of polygon 1 matches up with PQ of polygon 2. And you'll notice with both these polygons that they go in a clockwise fashion. A, B, C, D, E, P, Q, R, S, T, and their congruency tick marks match up in the same clockwise fashion. So polygon A, B, C, D, E must be congruent to polygon P, Q, R, S, T. Now in geometry, naming congruent polygons like we just did is known as naming the congruency. So if your teacher or a textbook or any sort of worksheet asks you to name the congruency of two different polygons, this is how you would do that.